In this section, we want to talk about different techniques for solving quadratic equations. A quadratic equation is a polynomial of the form ax squared plus bx plus c is equal to 0. That is, we're dealing with a polynomial expression of degree 2. One of the most common methods that seems to get used for solving quadratic equations is to use the quadratic formula. We're going to start with this approach because it seems to get ingrained in people's heads over the years. Personally, I don't necessarily think it's the best approach, but if it's one that you're comfortable with, it's definitely going to work. So we'll start off with the quadratic formula, which tells us that the solutions to this equation are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you already have this formula memorized, or if you want to take the time to memorize this formula, this is a great way to go about solving quadratic equations, though it does have the potential for a lot of minor errors. I know myself personally, I make small arithmetic errors, and there are just a lot of instances throughout this formula where we could make one of those small errors, which would throw off our answers. But we'll take a look at a few examples using this formula, and then we'll move on to some other techniques we can use. In example 1, we're given a quadratic equation. Our first two terms don't have a coefficient, but hopefully we understand that there's always a coefficient of 1 there. So our value for A would be 1, our value for B would be negative 1 in this case, meaning we can go ahead and substitute in our values for A, B, and C into the quadratic formula. So we would have the opposite of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 2. All over 2 times 1. Once we plug in all our values, a, b, and c, into the quadratic formula, now we just need to simplify this expression and get down to our potentially two different answers. Since we have this plus or minus symbol, we'll have to evaluate this expression in two different ways. Starting with that opposite of negative 1, those two negatives will cancel, giving us positive 1. Plus or minus the square root of negative 1 squared will be positive 1. Then we'll have minus 4 times 1 times negative 2. The two negatives will cancel out, giving us a positive 8 over 2. So this will be 1 plus or minus the square root of 9 over 2, or 1 plus or minus 3 over 2. Now we have to evaluate this expression by finding 1 plus 3 and then finding 1 minus 3 divided by 2. That means we'll come up with two different answers here. If we evaluate 1 plus 3 over 2, then we'll get 4 over 2, which will reduce to just 2 as one solution. 1 minus 3 will give us negative 2 divided by 2, or negative 1 as our second solution. Every time we evaluate the quadratic formula, that process will be identical. What will change in each case will just be our values for A, B, and C. So in example 2, we'll do the same thing. We'll plug in the opposite of our value for B, which is negative 22, plus or minus the square root of negative 22 squared minus 4 times 8 times 15. All of that over 2 times a, so 2 times 8. Our two negatives will cancel again, giving us 22 plus or minus the square root of 484 minus 480 all over 2 times 8, or 16, which will be 22 plus or minus the square root of 4 all over 16. The square root of 4 will just become 2, and then we'll have two expressions to evaluate again. 22 plus 2 will give us 24 over 16, or 3/2, once we reduce that fraction. 22 minus 2 will give us 20 over 16, or 5/4, once we reduce that fraction. Now we'll take a look at what should be example 3. And we'll run through one more iteration of applying the quadratic formula to solve a quadratic equation, which is going to be very similar to the previous few examples. And then the next couple examples we'll have to look at a slightly different approach or add an additional step or two. Since this quadratic equation is still in that standard form that we introduced back at the beginning of the video, we just plug in our values again. So this will be the opposite of 2 plus or minus the square root of b squared, so 2 squared, minus 4 times 6 times negative 20, all over 2 times 6. We'll jump through the steps a little bit faster here, but this should reduce to negative 2 plus or minus the square root of 484 over 12, or negative 2 plus or minus 22 over 12. From here, we'd evaluate this with both the plus and the minus, and we would end up with, again, two solutions, 5/3 and negative 2. One last thing we want to talk about with these first three examples is this value under the radical. It's referred to as the discriminant. The value under that radical can be positive, negative, or 0. In the three examples we've looked at, we've had a positive value for the discriminant, and the result means we ended up with two solutions. If the value under the radical was equal to 0, we would only have one solution to the equation. And the other possibility is that the value under the radical could be less than 0. That would mean we end up taking the square root of negative 1, which gets into complex numbers, imaginary numbers, but that's not something that's part of the scope of this course. So as a little bit of a red flag to yourself, just keep in mind, for this course, whatever value we get under the radical should be a positive. If you end up with a negative value under the radical, you've made an arithmetic error or a substitution error somewhere along the way.